Whoops. Okie dokie, so this is another example. So if I just draw, we had 50 centimetres cubed of hydrochloric acid. So 50.0 centimetre cubed of hydrochloric acid. Into that we added 50 centimetres cubed of NaOH solution. So my total, what total volume of water will I now have? 50 of that, 50 of that. In my reaction, I've now got a total of 100 centimetres cubed. Yeah. And into that I had my thermometer, and my temperature went up by 6.8 degrees C. So the key thing to remember is you've got to add that volume to that volume. For water, you can assume that 1 centimetre cubed of water has a mass of 1 gram. So you just use volume in the next equation. So the first step I have to do is calculate the energy produced. So the equation that we used last time was the energy in joules equals the mass of water times the specific heat capacity of water times the temperature change. If I do that, that comes to 100 times 4.2 times 6.8. And that equals 2,856 joules. How do I measure enthalpy? I always measure enthalpy in kilojoules. So how can I convert it into kilojoules? Yeah, so it's 2.856 kilojoules. So that's the first step. So I've calculated the energy produced. What do I now need to work out? The number of moles of reactant. So, if you think about it, I've got two things. I can use either HCl or I can use NaOH. Does it matter which one I use? It's going to give me the same number, isn't it? So let's work out moles of HCl is concentration times volume over 1,000. Concentration is 1.0. The volume is 50.0 over 1,000. Which is actually 0.05 moles. Next step that I do to calculate therefore delta H is equal to energy divided by moles, which is going to be that number divided by 0.05, which gives me 57.12 kilojoules per mole. What do I now need to do? What do I need to add here? Minus. Why is it a minus?
Because it's an extra.
Yeah, it went up by 6.8 degrees C. So that's my final answer there. So we've got the copper sulfate, we've got the magnesium, temperature went up by 25.1 degrees C. Let's work out, first of all, the energy. So energy in joules is equal to the mass of water times my specific heat capacity of water, which we know is 4.18, times the temperature change, which they told me is 21.5. So the only thing I need to substitute my mass of water. My mass of water is going to be... Do I need to worry about the magnesium powder? I'm going to ignore that. So the mass of water is 100 grams. So it's going to be 100 times 4.18 times 25.1 do that. That equals 10,492 joules, but we convert to kilojoules, so 10.492 kilojoules. Now, I need to think about, it's told me which one, I have to work out which was in excess. So let's have a look at that. First of all, let's do moles of copper sulfate that I use. It's a solution, so it's going to be concentration times volume over 1,000, which is going to be 0.20 times 100 over 1,000, which is going to be 0.020 moles. Happy with that? Moles of magnesium is going to be mass over molar mass, which is 2.0 grams, 2.0 divided by 24.3. Let's do that. 2 divided by 24.3. That gives me 0.0823. So, which one was in excess? Which one did I have too much of? Magnesium, brilliant. So I'm not going to use magnesium because I have way too many moles of magnesium. It should be, you need to remember to look at the equation, it should be 1 to 1. So if I had 0.02 moles of copper sulfate, I should have had the same as that, but I actually used too much. So I'm going to use that number because that one was in excess. So on to the final bit now. Delta H is going to equal 10.492 divided by 0.020. That equals 524.6 kilojoules per mole. Always think, is it ex or endothermic? What temperature went up? So what side do I need to stick there? Minus, brilliant. And that's my answer.